Okay, so today we're going to look at factorising quadratics, and I hope this will help you. We start simple with single bracket factorisation, and we're going to build it up to double bracket factorisation. So let's start off with single bracket factorisation and thinking about things you should already know. So if we have a look at 7x squared plus x, and your first step here is to look for a common factor. So you're going to look at what's the same in 7x squared and what's the same in x. And if we look at that, hopefully you can see that the thing that's the same is the x. Because what 7x squared means is 7 times x times x. So we're saying, well, this means 7 multiplied by x multiplied by x. So the thing that's the same in both of them is an x. So when we factorise this, we can take the x outside the bracket because it's the common factor. And we say x times what gives us 7x squared? Well, we've got to times it by the 7 and by another x. And x times what gives us just x on its own. The only thing that makes sense there is 1. So we've taken out a common factor. So now let's take another example. Let's have a look where there's more than one common factor. So let's have a look at 6x squared plus 14x. And we're going to say, what? Now we've got to think of the numbers separately and the algebraic bit, the x's, the a's, the b's separately. So let's have a look at the numbers. So if we take our numbers, we're comparing the 6 and the 14. And we're saying what goes into 6 and what also goes into 14. And in terms of our times table, the only thing there is going to be 2. So I'm going to say, I've got, when I'm factorising, I know I can take a 2 out. Then I look at x squared and x. Well, they both have an x in them. And now I say to myself, how do I go from 2x to 6x squared? So let's do it in steps. 2 times 3 gives us the 6, and x times x gives us the x squared. 2 times 7 gives us 14, and we've already got the x outside. So we've now factorised that. Right, so what I'm going to do now is let's take something a little trickier that we might need to think about a little more because we've got some more letters involved. So if we have, let's take 6p to the 4q plus 8p cubed plus 10p squared q. So we look at that and go, oh, there's lots of things there. Let's break it down. Let's look at the numbers first. We've got 6, 8, and 10. Well, what goes into all of those? So the only thing that goes into all of those is 2. So I've identified and I've looked at my numbers and I've gone, okay, 2 goes into all of those. Now let's have a look at the p's. How many p's do I have? So here I've got p to the 4, so I've got 4, p times p times p times p. Got p cubed, so I've got 3, p times p times p, and p squared. So actually the amount that's in every single thing is p squared. And now I'm going to have a look at q. Well, q's only in 2 of them, so we can't take it out the whole bracket, so we just get our 2p squared on the outside. So now 2 times what gives me 6? 2 times 3. How many more p's do I need? I need 2 more, and I've got a q. 2 times what gives me 8? Well, that's going to be 4, and I've got another p there. And 2 times what gives me 10, and that's going to be 5. And I've already got the p squared, so the only thing I need there is a q. And I factorise that, and that's taking out my single bracket factorisation. So what I'm going to do is put up a series of about 5 questions. I suggest you pause it, attempt them, and then have a look at the answers and check that you agree. So the first question we've got is QR minus 2Q The second one, we're going to have 6x minus 3y. The third one, we've got xyz plus yz. The fourth one, got 5qr plus 10r. And the last one, which is a bit trickier, we're going to have 10x cubed y squared plus 5x squared y cubed plus 15x squared y squared. So here's where I suggest you pause it, you attempt these, and then you check the answers, which I'm going to put up now. So here our common factor is q, and we've got r minus 2. Here our common factor is 3, and we've got 2x minus y. Here our common factor is a y and a z, and we're going to get x plus 1. In this one, our common factor is 5r, and we're going to have q plus 2. And this final one down here, our common factor is 5x squared y squared, and we're going to get 2x plus y plus 3. So in terms of single bracket factorization, hopefully that makes some sense. So to follow on from that, so now this takes you to the foundation GCSE. If you want to extend your single bracket factorization a little further, so this will take you, if you're doing any of the GCSE further maths papers, this is a skill that you need to know, and it's when you take out an entire bracket. So let's have a look at that while we're on single bracket factorization. So if I was to factorize, so for example, if I had a minus b all squared plus a plus 3 a minus b. So it's the same logic. If you look here, you're saying, what's the common factor? My common factor here is a minus b. So I'm going, okay, I've got that as a common factor. Let me take it outside the bracket. So I'm going to take a minus b outside an entire bracket. And I'm like, well, what have I got left? What do I times a minus b by to get a minus b squared? I've got to multiply it by another a minus b. And for the next one, I need to multiply it by a plus 3. So now I can put that together. I get a plus a to give me 2a. I've got a minus b there, and I've got a plus 3. So now I've taken two separate expressions and made them a product of expressions, which is what factorizing is. So I hope that's useful. I think what we should maybe do is show you where that comes from. So if I take an AQA, this is an AQA further maths question from paper 1, and it asked you to factorize x plus y squared plus x plus y 2x plus 5y. So this was the June 2012 paper. And so we're going to look for it, and we're going to look for our common factor. And our common factor is x plus y. So that's what's going to go outside of everything. So I'm going to take x plus y outside, and I say, what am I multiplying it by to get x plus y squared? I'm multiplying it by x plus y. And then in the other one, I'm multiplying it by 2x plus 5y. I'm then able to simplify that. So x plus y. And in here, I'm going to get x plus 2x to give me 3x, and y plus 5y to give me 6y. And now maybe you notice that you can take another factor outside. You can actually take the 3 outside, and you're going to get x plus y, x plus 2y. So now we're going to look at factorizing equations when they're in the form x squared plus bx plus c. So the first thing we're going to look at is just to look at some patterns and how these work. So let's take x plus 4, x plus 2. Now, if we were to open this out, using the technique that you know to open it out, so either use a smiley face or you multiply everything by x first, you end up with x squared plus 6x plus 8. What if we have x plus 2, x plus 3? When we open this out, we get x squared plus 5x plus 6. Let's do one with a negative. X plus 4, x minus 3. So we get x squared plus, and we're going to get 4x minus 3x to give us plus x minus 12. So what do you notice? Just looking at these, what can you see? So what hopefully you notice is that the middle term here is always the sum of these two. So plus 4 plus 2 gives you 6. 2 plus 3 gives you 5. And 4 minus 3 gives you 1. And that's where that term comes from, that B term. Now let's have a look at where the other number comes from. And that's the product. So here the 8 comes from doing 4 multiplied by 2. 6 comes from 2 multiplied by 3. Minus 12 comes from 4 multiplied by minus 3. So we're going to look at the, at the sum product rule for doing these. So we're essentially going to look at both numbers and we're going to say what numbers can we find to add to something and to multiply to it. It gets trickier when we get a letter in front, but I'll show you a really cool trick for that. But for the moment, we're looking at factorizing in this form. So x squared plus bx plus c. So let's take a look at an example. So say we have x squared. Let's do x squared. Let's do some plus 6x plus 5. So you're saying to yourself, I want two numbers that multiply to give me 5 and add to give me 6, right? So I think, okay, my 5, well, this one's really easy because we've only got one thing it can be, 5 and 1. And we know when we add 5 and 1, we get 6. So we're going to get x plus 1, x plus 5. All right, let's make it a little bit trickier when there's more than a few options. So let's have a look at x squared minus 2x minus 24. So remember, for this one here, this is the one that has to add up. And this one here is the one we want to multiply to give me. So we look at the one to multiply and we think of all the different factors. So what are the factors of 24? So you've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, and we want to add them to get minus 2. But remember, one of them has to be negative because otherwise we won't end up with minus 12. So I can look at that and I think, okay, so if it's negative, it really means taking them away. And hopefully you can see I'm going to use 4 and 6. Now you mentally might do that, but you're going to try think about it. So you've got to visualize the numbers. Writing them out initially is not a problem. As long as you get the question right, it doesn't matter how you got there. So then that's going to end up being x, and we know we're going to use 6 and 4, and we want minus 2. So the bigger number needs a minus in front of it, and then we've got plus, right? So that's how you use the sum multiply method, or the, product and sum method. Negative ones are the trickier ones. If you practice them lots, you should be able to get your head around them. So we're now going to look at the trickiest ones, the ones that come up in a higher paper, where you've got to factorize something of the form ax squared plus bx plus c. But there's a really, really cool trick you can use. Well, I think it's cool, but I am a maths teacher. So if you've got 2x squared plus x minus 3. And you might think, oh, I can do this, I can see it, but I'm just using this to illustrate. We know how to do things for x squared, but we've got this annoying 2 in the front. So we're going to, the 3 is going to borrow the 2 temporarily. So we're going to do 3 times 2 to give us 6. So we end up with x squared plus x minus 6. And then we factorize that how we normally would. So if we were to normally factorize that, we'd say x and x, we'd look at factors of 6. So we've got 6 and 1, that doesn't work. We've got 3 and 2, that works because we can have plus 3 minus 2. But the x wants its 2 back. So we've got to give the 2 back to the x's. So we get 2x minus 2 and 2x plus 3. But now we have to divide by the highest common factor of each bracket. Now for 2x plus 3, which is just 2x plus 3, it stays the same. But in the first bracket, we can divide by 2, and we get x minus 1. Now if you were to open that out, you'll find you've got your quadratic. Okay, let's take a slightly trickier example. Let's take another example. So let's go to the next page, and let's have a look at, all right, let's take one from exam paper. 12x squared plus 17x minus 5. So now we've got this irritating 12, which we have to deal with, but 5 is going to borrow it. 12 times 5 gives you 60. So you're going to get x squared plus 17x minus 60. And now you use your regular sum and multiply rule. So 2 brackets, x and x, I think of my factors of 60, and hopefully your brain would twig you've got 20 times 3. And if you do plus 20 and minus 3, you're going to get 17. So now we borrowed the 12, we've got to give it back. So 12x minus 3 and 12x plus 20. So what can we divide 12 and 3 by? They both divide by 3. So this bracket here is going to become 4x minus 1. And 12 and 20, they both divide by, well, we divide them by 2, we get 6 and 10, and we can divide again. So we get 3 and 5. So we divide by 4, and we get 3x plus 5. And you've now factorized something that's quite, well, looks a bit trickier to factorize and made it easier to do so. Let's take one final example. So if we take 4x squared minus 9x minus 9. So we're going to borrow the 4. 4 times 9, now if you don't know how to do your sort of 9 times table on your hands, oh, that's the wrong way, I know, 36. So you've got 3, you put your 4th finger down, so you've got 3 here, and then you've got 6 here, so you've got 36. So x squared minus 9x minus 36, right? And we think of our factors of 36, which have a difference of 9. So I'm going, okay, 36 and 1, 3 and 12, or 12 take away 3 is going to give me 9. So I'm going to go 12 and 3, and I want minus 9. So it's going to be minus 12, sorry, plus 3. And then we've got to give the 4 back. So now we have 4x plus 3, 4x minus 12. So 4x plus 3 stays the same because we can't divide by anything. But 4x minus 12, we can divide through by 4, and it gives us x minus 3. So I hope that's useful. I think it's a really good trick to have, and it makes factorizing these quadratics a lot easier.